In this video, we will learn about binomial expansion. As the name suggests, this is the general procedure of expanding a binomial raised to an exponent. Binomial expansion consists of 4 steps. The first one is to write the expressions, in which the terms follow a pattern. For example, this is the binomial expansion of the binomial a plus b raised to the exponent n. So the pattern is that the first term of the expansion is the first term of the binomial a raised to the given exponent n times the second term of the binomial b raised to the exponent 0. For the succeeding terms, we have to subtract 1 from the exponent of a while adding 1 to the exponent of b. That is we have to do that incrementally. Okay, so such that the second term of the expansion is a to the n, subtract 1 from that, so we have a to the n minus 1. And b to the 0, add 1 to that, so we have times b to the 1. For the third term, we have a to the n minus 1 minus 1, that is a to the n minus 2. And b to the 1 plus 1, that is b squared. So we have to follow that pattern until we reach a to the 1 times b to the n minus 1, and the expansion ends when the expression becomes a to the 0 times b to the n. Now, one thing that we have to remember about binomial expansion is that the sum of the exponents in each term of the expansion is equal to the given exponent. So if we add the exponents in this term, okay, we should get the given exponent. Okay, so n plus 0, of course, is n. N to the n minus 1 plus 1, that is also n. Add n minus 2 and 2, that gives us n. Add 1 and n minus 1, that also gives us an n. And 0 plus n is also n. Another thing that we have to remember is, according to one of the laws of exponents, b to the 0 is equal to a to the 0. Yes, both are equal to 1. So in other words, given an expression or a non-zero number, if you raise that to the exponent 0, we get the value of 1. Okay, such that here in the first term, b to the 0 is simply 1. So if we simplify this term, we only have a to the n. And a to the 0 is 1. So if we simplify the last term, that is only b to the n. The next step in binomial expansion is to determine the signs of the terms. For example, we have the binomial a plus or minus b raised to the given exponent n. Okay, there are two cases. The first one is if the operation in the given binomial is addition, all terms in the expansion are positive. So if this is a plus b, then we have this term plus second term plus third term and so on, plus second to the last term and plus the last term. The second case is if the operation is subtraction, in this case the signs of the terms are alternately positive and negative. Again, the signs of the terms in the expansion are alternately positive and negative. So we have to remember that the first term in the expansion is always positive. So if the binomial here is a minus b, then this is again the first term is always positive, so plus. So the second term should be minus, third term plus, fourth term minus, and so on. Okay, until we reach the last term. Okay, the third step in binomial expansion is to determine the coefficients. When we say coefficients, of course, these are the numbers multiplied to the expression in each term. Okay, so to determine the coefficients of the terms, okay, we have to use what we call the Pascal's triangle. What is a Pascal's triangle? Okay, it is basically a triangle consisting of numbers. It starts with three ones. So we have 1, 1, 1 that seem to act as vertices of a small triangle. One thing that we have to remember about Pascal's triangle is that each line in this triangle refers to a value of the exponents. Okay, such that this one refers to, or rather represents the case when the given exponent n is equal to 0. Because, for example, if you have the binomial a plus b, if you raise that to 0, then we know that an expression raised to 0 is 1, so we have only 1. Okay, when n is equal to 1, for example, we have a plus b binomial. If we raise that to 1, then the answer is the same binomial, a plus b, because anything raised to 1 is equal to any number, any expression raised to 1 is to the exponent 1 is equal to the number or the expression. So we have a plus b, or 1a plus 1b. Okay, so again, we have to start with 1, 1, 1, then 1 and 1. Okay, how do we get the succeeding lines? The succeeding lines are obtained by getting the sum of two adjacent numbers and adding 1 on both sides of the list. Okay, so for example, how do we get this 1 to 1 line for the n equals to 2 from the previous line? So we have here 1 and 1. These two numbers are adjacent, so we add them. So 1 plus 1, that is 2. And we have to add 1 on both sides of the list. Okay, for the coefficients, when the given exponent n is equal to 3, okay, so we use this line to obtain the next line. Yeah. So we have 1 plus 2, two adjacent numbers. 1 plus 2, that's 3. 2 plus 1, that is also 3. And we have to add 1 on both sides of the list. The fourth step in the binomial expansion is to simplify the terms. Let's consider some examples of binomial expansion. Okay, first is the case when n is equal to 1. So let's say we have the binomial x plus y. If we raise that to the exponent 1, we get the same expression. X plus y is x plus y. Okay, so recall that in the Pascal's triangle, 1, 1, this line represents n is equal to 1. Okay, that's because we have here 1x and 1y, 1, 1. Okay, how about the case when n is equal to 2? Let's say we have the binomial x minus y, and we have to raise that to the exponent 2. Okay, so first step, write the expression. So the expression, for that, we have the first term of the binomial x raised to the given exponent 2, okay, times the second term y raised to the exponent 0. But we know that y to the 0 is 1, so we only have x squared in the first term. For the second term, okay, we have to subtract 1 from the exponent of x. That's x to the 2 minus 1. So that's x to the 1, or simply x. And, okay, for the y, we have y to the 0 here. And we have to add 1 to that exponent. So we have y to the 0 plus 1. That is y to the 1, or simply y. Okay, next term. Okay, x to the 1 minus 1. That's x to the 0. So that simplifies to 1. Okay, and y to the 1. Y, of course, is y to the 1. Plus 1, that's y squared. Okay, and since the second term here, and since in this term, the second term of the binomial is already raised to the given exponent, we know that this is the last term. Okay, second step is to determine the signs. Okay, so the operation in the given binomial is minus. Therefore, the terms in the expansion are alternately positive and negative. So the first term is always positive. Therefore, the second term should be negative, and the third term is positive. Okay, next step rather is to determine the coefficients of the terms. Okay, for that we look to the Pascal's triangle. Okay, for n equal to 2, the line consists of the numbers 1 to 1. Okay, so uh, 1 to 1, that's why we have here 1x squared or simply x squared. 2 times xy, the expression xy. Okay, and then 1, yeah, 1. So we have here 1 times y squared or simply y squared. Okay, the last step is to simplify the terms. Okay, but we can no longer simplify any of the terms in this expression. So this is the final answer. Okay, next, what if the given exponent n is equal to 3? Let's say we have x plus y that is raised to the exponent 3. Okay, first step, write the expressions. So we have the first term of the binomial x raised to the given exponent 3. Okay, times the second term y raised to 0. Y to the 0 is 1, so we only have x cubed. For the next term, we have to subtract 1 from the exponent of x. So we have x to the 3 minus 1, that's x squared. And we have to add 1 to the exponent of y. So we have y to the 0 here, plus 1, that is y to the 1, or simply y. Next, we have x to the 2 minus 1. So you have x to the 1, or simply x. And y to the 1 plus 1, that is y squared. Okay, next we have x to the 1 minus 1, that is x to the 0 in this term. So that is simply 1. And y to the 2 plus 1, that is y cubed. Since the second term of the binomial is now raised to the given exponent 3, this is the last term. Okay, how about the signs of the terms? Since the operation in the given binomial is addition, okay, we are sure that all the terms in the expansion are positive. Okay, next step is to determine the coefficients. Okay, if we look at the Pascal's triangle, yes, the line for n is equal to 3 consists of 1, 3, 3, 1. That's why we have here 1 x cubed or simply x cubed. Then we have here 3 times this expression. We also have here 3 times this expression, and we have 1 in the last term or simply y cubed. Okay, the last step is to simplify the terms, but we cannot simplify any of these terms further. Therefore, this is the final answer. Okay, next, what if n is equal to 4? Let's say we have x minus y raised to the exponent 4. Okay, first step, write the expression. So we have the first term of the binomial raised to the given exponent. So we have x to the 4 times the second term of the binomial y raised to the exponent 0. So we only have, since y to the 0 is 1, we only have x to the 4. Okay, the expression for the second term is, okay, we have to subtract 1 from the exponent of x. So x to the 4 minus 1, that's x cubed. And we have to add 1 to the exponent of y. Of course, we have in the first term y to the 0. So y to the 0 plus 1 is y to the 1, or simply y. Next, x to the 3 minus 1, that's x squared. And y to the 1 plus 1, that's y squared. Next, for the next term, we have x to the 2 minus 1, that's x to the 1, or simply x. And y to the 2 plus 1, that's y cubed. Okay, for the next term, we have x to the 1 minus 1, that is x to the 0, or simply 1. And y to the 3 plus 1, that is y to the 4. Okay, and this is the last term. Okay, next step, what are the signs of the terms? Since the operation in the given binomial is subtraction, okay, the terms in the expansion are alternately positive and negative. So the first term is always positive. Okay, the second term is minus, third term plus, fourth term minus, and the fifth term is plus. Okay, next step. Okay, how about the coefficients of the terms? Where did we get 1, 4, 6, 4, 1 from the Pascal's triangle? Okay, from this Pascal's triangle, we know that the line for n is equal to 3 consists of 1, 3, 3, 1. So we have 1, 3, 3, 1. How do we get the line for n is equal to 4? Consider two adjacent numbers, okay, get their sum or add them up. So we have 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and we have to add 1 on both sides of the list. That's why we have these coefficients, 1, okay, 4, 6, 4, and 1. Okay, the last step is, can we simplify any of these terms further? No, therefore this is the final answer. Now let's try to expand some binomials. First, let's say we have the binomial x plus y, and we have to raise that to the exponent 5. How do we expand this binomial? Okay, first, write the expressions. So we have the first term of the given binomial raised to the exponent, to the given exponent 5. So we have x to the 5 times we have the second term of the given binomial y, and we have to raise that to 0. Y to the 0, but y to the 0 is 1, so we only have x to the 5 in the first term. For the second term, we have to subtract 1 from the exponent of x. Okay, so we have x to the 5 minus 1, that's x to the 4. And again, remember, we have here y to the 0. Okay, we have to add 1 to the exponent of y. So we have y to the 0 plus 1, that's y to the 1, or simply y. Okay, next term, we have x to the 4 minus 1, that's x cubed. Y to the 1 plus 1, that's y squared. Okay, for the next term, we have x cubed, x to the 3 minus 1, x squared. Y squared, or y to the 2 plus 1, that's y cubed. Okay, next we have x to the 2 minus 1, that's x to the 1 is simply x. And 3, rather y cubed, y to the 3 plus 1, that is y to the 4th. Okay, for the next term, we have x to the 1 minus 1, 0. So you have x to the 0. Therefore, in this term, we have 1 times y to the 4 plus 1, that is y to the 5. Okay, since this is the second term of the binomial raised to the given exponent 5, and the x has been eliminated in this term, we know that this is the last term. Okay, next step. Okay, how do we determine the signs of the terms in the expansion? Well, since the operation in the given binomial is addition, okay, we are sure that all terms in the expansion are positive. Okay, third step, um, we have to write in here the coefficients of the terms. Okay, for the coefficients, of course, we have to use the Pascal's triangle. Okay, from the previous example, we know that the line for n is equal to 4 consists of the numbers 1, 4, 6, 4, 1. So how do we get the line for n equal to 5? Okay, consider two adjacent numbers, 1 plus 4, that's 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And we have to add 1 on both sides of the list. Okay, so these numbers, okay, are the coefficients. So we have to insert, okay, each of these numbers into each of the terms of the expansion. Okay, so we have here 1 times x to the 5, that's x to the 5. 5 times x to the 4y, that's 5x4y. 10 times x cubed y squared, that's 10x cubed y squared. 10 times x squared y cubed, 10x squared y cubed. 5 times x, this should have been x, simply x. Okay, so so we have 5 times xy to the 4 is 5xy to the 4 plus 1 times y to the 5 is y to the 5. Okay, if uh, if this has been written as x only, then this expression cannot be simplified further. Therefore, this is the final expansion. The second problem is we have to expand the binomial x minus 2 that is raised to the exponent 4. Okay, first step is to write the expression. So we have the first term of the binomial x raised to the given exponent of 4. So we have x to the 4 times the second term 2 raised to the exponent 0. So 2 to the 0 is 1. So we only have x to the 4 in the first term. Okay, for the next term, we have to subtract 1 from the exponent of x. So we have x to the 4 minus 1. That is x cubed. And then we have to add 1 to the exponent of 2. Okay, remember we have here 2 to the 0. So 2 to the 0 plus 1 is 2 to the 1 or simply 2. Okay, next term, x to the 3 minus 1. That's x squared. 2 to the 1 plus 1. That's 2 squared. Okay, x to the 2 for the next term, x to the 2 minus 1, that's x to the 1 or simply x, and 2 to the 2 plus 1, that's 2 cubed. Okay, for the next term, we have x to the 1 minus 1, that is 0. So we have here x to the 0 or simply 1, and 2 to the 3 plus 1, that is 2 to the 4. Since since the first term of the given binomial is eliminated or has been eliminated in this term, we know that this is the last term. Okay, how about the signs of the terms for the second step? Okay, we know since the operation in the given binomial is subtraction. Okay, we know that the terms in the expansion are alternately positive and negative. We know that the first term is always positive. So the second term is minus, third term is plus, fourth term is minus, and fifth term is plus. Okay, so third step, we have to insert the coefficients of the terms. Okay, so from the Pascal's triangle, we know that the line for n is equal to 3 consists of the numbers 1, 3, 3, 1. So for the line for n is equal to 4, we have to add two adjacent numbers. So 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and add 1 on both sides of the list. Okay, so if we insert these coefficients, okay, into the terms, we have 1 times x to the 4, that's x to the 4. 4 times x cubed times 2, that is this expression. 6 times this expression is this third term. 4 times this expression is, we have this one. Okay, and lastly, 1 times 2 to the 4 is simply 2 to the 4. Okay, obviously, we can still simplify the terms this expansion. Okay, so x to the 4, okay, we can no longer simplify that, so we simply copy. Okay, x to the 4. How do we simplify this term? Well, first we have to multiply the numbers. So we have 4 times 2, 8, and the only expression, and the remaining expression is x cubed. Okay, let's simplify the numbers. First, let's raise this 2 to the exponent 2. So 2 squared, that is 4, times the 6, that is 24, and the remaining expression is x squared. Okay, let's simplify the numbers. So first, raise this 2 to the given exponent 3. So we have 2 cubed. 2 times 2, 4 times 2, 8, times this 4, that is 32 minus 32, and the remaining expression is x. Okay, plus, okay, last term, we have 2 to the 4. 2 times 2, 4 times 2, 8 times 2, 16. So we have plus 16. And this is the binomial expansion of this expression. For the third problem, we have to expand the binomial 2y minus z that is raised to the exponent 3. Okay, first, let's write the expressions. Okay, for that, we have the first term of the binomial, that's 2y. Okay, we have to raise that, okay, the entire 2y, remember? Okay, we have to raise that to the given exponent 3. So we have 2y quantity 3. Okay, times the second term of the binomial z, we have to raise that to the exponent 0, so z to the 0. And z to the 0 is simply 1, so we have only this expression in the first term. For the second term, we have, okay, we have to subtract 1 from the exponent of 2y. So we have quantity 2y raised to the 3 minus 1, that is 2. And then we have to add 1 to the exponent of z. So remember, we have here z to the 0. So z to the 0 plus 1, that is z to the 1, or simply z. Next, for this term, we have quantity 2y to the 2 minus 1. So we have 2y. Okay, the quantity 2y, or quantity 2y to the 1, or simply 2y. And then we have z to the 1 plus 1, that is z squared. Next, quantity 2y to the 1 minus 1, that is 0. So we have quantity 2y to the 0. That is 1. So we have here 1. Okay, times z to the 2 plus 1, that is z cubed. Okay, and since 2y has been eliminated in this term, this is the last term. Okay, next step. How about the signs of the terms? Since the operation in the given binomial is subtraction, uh, we should know that the terms in the expansion are alternately positive and negative. Yes, we know that the first term is always positive, so the second term is minus, third term is plus, and fourth term is minus. Okay, next we have to determine the coefficients of the terms. For that, we have to use the Pascal's Triangle. Okay, so we know that in a Pascal's Triangle, the line for n is equal to 2 consists of the numbers 1, 2, and 1. So to get the line for n equals 3, we have to add the adjacent numbers. So we have 1 plus 2, that is equal to 3. 2 plus 1, that is equal to 3, and we have to add 1 on both sides of the list. Okay, so we have to insert these coefficients into the terms of the expansion. So we have 1 times that expression, so we have that expression. Because 1 times anything except when 1 of course is multiplied by 0, okay? And any non-zero expression times 1 is the expression. Okay, so 3 times this expression, so we have a 3. 3 times that expression, so we have this 1. Okay, the leading coefficient is 3. And 1 times z cubed is z cubed. Obviously, we can still simplify the terms in this expansion. Okay, so how do we do that? We start with numbers. So we have, of course, when we have quantity 2y raised to 3, that means we have to raise each factor to the exponent 3. So let's start with the numbers. So we have 2 cubed. 2 times 2, 4 times 2, 8. Okay, then we have y to the 3. That's y cubed. Okay, minus. Let's see. We have here the exponent. So let's raise these factors to y to the exponent 2 first. So we have 2 squared. 2 times 2, 4. Times 3, that is 12. Okay, and the remaining expression is y to the 2, or y squared, times z. Okay, plus, okay, so let's multiply the numbers. 3 times 2, that is 6. And the remaining expression is yz squared. So we have yz squared minus, copy the z cubed. Okay, and this is the binomial expansion of this expression. For the last problem, we have the binomial 2p plus 1, okay, that is raised to the exponent 4. How do we expand this binomial? First, let's write the expressions. Okay, so we have the first term of the given binomial. Okay, that's quantity 2p. We have to raise that to the given exponent 4. Okay, times the second term of the binomial 1. We have to raise that to 0. So we have 1 to the 0. That is simply 1. So we only have the quantity 2p raised to the exponent 4 in the first term. for the next term, we have to subtract 1 from the exponent of quantity 2p. Okay, so we have quantity 2p to the 4 minus 1. That is quantity 2p to the 3. Okay, and next, we have to add 1 to the exponent of 1. Remember, we have here 1 to the 0. So we have 1 to the 0 plus 1. That's 1 to the 1 or simply 1. For this next term, we have 2p, quantity 2p to the 3 minus 1. That's quantity 2p to the 2. Okay, times, okay, 1. This is 1 to the 1 plus 1. That is 1 squared. Okay, for the next term, we have quantity 2p to the 2 minus 1. So quantity 2p to the 1 is simply 2p. And then we have 1 to the 2 plus 1. That is 1 cube. Okay, plus, okay, for the next term, we have quantity 2p to the 1 minus 1. That is 0. So we know that quantity 2p to the 0 is 1, simply 1. Okay, and we have 1 cube, 1 to the 3 plus 1. That is equal to 1 to the 4. Okay, how about the signs of the terms? Okay, we know that the operation in the given binomial is addition. So we are sure that all the terms in the expansion are positive. Okay, next step is to determine the coefficients of the terms. Okay, we know from previous examples that the line in the Pascal's triangle, for n is equal to 4, consists of the numbers 1, 4, 6, 4, 1. So we have to insert these coefficients into the terms. Okay, so 1 times that expression, we have this one. 4 times that, we have this expression. 6 times this, times the third term is we have this expression. 4 times that is this one. And 1 times 1 to the 4 is this expression. Now, obviously, we have to simplify the terms further. Okay, so to do that, we have, again, quantity 2p to the 4. For that, we have to raise each factor to the exponent 4. Okay, so we have 2 to the 4, 2 times 2, 4, times 2, 8, times 2, 16, times 1, that is 16, and the remaining expression is p to the 4, so we have times p to the 4. Okay, next term, we have, let's start with the exponent. We have 2 cubed, that is 2 times 2, 4 times 2, 8, that's 8. Times this 4, 32, times 1, still 32, so we have 32. And the remaining expression is p to the 3, so we have p cubed. Okay, next term, we have this exponent. Let's start with that. So 2 squared, that is 2 times 2, 4, times 6, 24, times 1 squared. 1 squared is simply 1, so 24 times 1 is 24. And the remaining expression is p to the 2, or p squared. Next term, we have 4 times, 1 cube is simply 1. So 4 times 2 is 8. And the remaining expression is p plus 1 times, 1 to the 4 is 1 times 1 is still 1. Okay, so this is the binomial expansion of this expression. If you have any question, please leave a comment.